Just a question around it. How did you get into it? Like, what was the thing that made your head turn and go, oh, old stuff?
You directed that to Brad?
No, Randall, sorry.
Oh, me. Oh.
Yes.
We did a little bit of that last go around.
Of course, Brad, I will ask you as well. Absolutely. Hey. But Randall first.
Well, I've been asked that question quite a bit, and I've tried to pinpoint whether there was any specific moment where like I had this epiphany, and there wasn't really. It was just a slow kind of accumulation of things. The main thing I would attribute it to, though, is growing up in rural Minnesota, and where we lived was right on the edge of the Great Ice Sheet. So for, tens of thousands of years, these ice sheets came down, they receded, they expanded, they receded. And right in that zone is where I grew up. And, I was always fascinated by the landscapes around me. The lakes and the hills always seemed to be like, I guess with most people would kind of like a hill is just a hill. I would be going, oh, why is that hill standing there like out in the middle of the field? Why is there a hill right there? Mm-hmm. One of the things was going with my, our family used to go up to a place called St. Croix Falls, which is on the St. Croix River, wild and scenic river that marks the boundary of Minnesota and Wisconsin. And there's a confluence there in a narrow constriction that's very hard basalt outcrops. And we used to go there as kids, and up on the basalt outcrops that are maybe 60 to 70 feet above the present river, there's like almost like shelves. And then in the surface of these are these deep potholes. Some of them are up to 80 feet deep and 20 feet wide, circular holes that have been drilled into the bedrock. So go there as a kid, and like it had something to do with the Ice Age, but very, very vague what that was. So I think it was 1969. I went up there with some friends, and we were doing some things that were probably not legal at the time, and probably maybe still aren't. But anyways,
oil painting.
Yeah, there we go.
Wink, wink.
Yes. But I remember having this sense that what happened here? What would drill these holes in the rock like this? So that was kind of planted the seed. And then, there was another event where, and I've told this story, but it was outside of Minneapolis, south of Minneapolis. There's the Minnesota River that flows into the Mississippi right there by St. Paul, Minnesota. There was a bluff above the river, about 200-foot high bluffs, and there was a flat area up there that was flat enough that they had an airport there. Next to the airport, they used to have rock concerts in the late 60s, early 70s, and I used to go to those rock concerts, and sometimes I would wander away from the group, and I would stand up on that bluff, and right down below is the Minnesota River. Now, there was a time, one day I was standing there looking down, and there was the Minnesota River flowing through, and I was looking at the Minnesota was kind of flowing within the banks, right? Mm-hmm. There was, and you kind of meandering, and then you could see the banks, and then 3 miles across was another set of bluffs that kind of matched the bluffs I was on. And I remember standing there and kind of going, that's kind of like a smaller version, or this is like a bigger version of what I'm looking at down there. It was in my mind, and then I kind of forgot about it, but it always stuck in my mind. And then the following summer, which was the summer of 1970, me and a buddy just spent the whole summer traveling, hiking, hitchhiking around all of the Western states. And what really impressed me, there was a couple of things. Flaming Gorge in Wyoming was very impressive. And I remember camping on the edge of the gorge and looking in there and really starting to get this sense of, okay, because the usual explanation is you look at something like that, it's millions and millions of years of geological change, one grain of sand, one drop of water at a time. But what really impressed me was going through the Columbia Gorge across the Cascades where it cuts through. And there are these tributary rivers that come in, and at the mouths of these tributary rivers are these massive delta fans. You know what a delta fan is? A delta, you know what a delta? Okay, no. A delta is when a river is carrying sediment and it's moving water and it comes into a standing body of water. The sediment that it's carrying will begin to build this fan-shaped formation under the water.
Yeah,
like the city of New Orleans is built on a delta, right? Because the Mississippi River has come down, carried enormous amounts of sediment, and deposited them in the Gulf of Mexico. So anyways, these fans were hundreds of feet above the river. Now, I didn't know anything about geology at the time, but there was something about them that just struck me as weird. Like, what is going on here? And so it was by 1970, I had really started getting curious about things,
Yeah.
And it didn't really gel for probably another 5 to 8 years. I think around 77, 78, I met somebody who was researching, they were writing a book. They turned me on to the work of Charles Hapgood, who was I think he was an anthropologist who
I've heard you mention him.
Yeah. So he was one of the small group of mid-20th century researchers that could be called catastrophists, who kind of thinking outside that strictly gradualist model that almost all geologists thought in terms of, right? So he was writing this book and utilizing a lot of Hapgood's work. So, and up to this point, I had a couple of things. I had gotten really interested in I was always interested in mythology. So that was an important parallel pathway that eventually merged in.
Right.
And at that point, I had become familiar with Greek mythology and the myth of Deucalion and Pyrrha, who were the survivors of the Great Flood in ancient Greece. And then the Norse mythology, Ragnarok, and the wars of the gods, and the Midgard serpent that wrapped around the earth, and all of these kinds of things. My head was filled with these mythic images of these tremendous things. The myth of Phaeton, Phaeton was the son of Helios that fell to earth and set the world on fire. And I'm going to be getting into that. I did get into some of that in my Atlantis, because Plato, in his account of Timaeus, he introduces the story of Atlantis by making a reference to the myth of Phaeton, which I think is auspicious.
Yeah, parallels to like the Younger Dryas comet. Yeah.
So then you've heard of the Hopi Indians of the southwestern United States. The Hopis. Yeah. Okay, so the Hopis are an ancient tribe. They live out in the Four Corners region of the Southwest. They're descended from the ancient Chacoan people who built all these mysterious structures all over the Southwest, the San Juan Basin in New Mexico, the Four Corners area around Colorado, Utah. Mm-hmm. So in the early 70s, I read a book about their mythology by Frank Waters, and he was talking about their concepts of 4 worlds that preceded this one, and they were all destroyed by these great catastrophes. And then they had prophecies that eventually, if we didn't start paying attention to the plan of the creator, this world would be destroyed in a catastrophe. I had a lot of that kind of mythic imagery in my head by the late 1970s, when I read, Velikovsky, Emmanuel Velikovsky, who was sort of the dean of catastrophist thinking back in the 50s, 60s, and 70s. And he wrote a book called Earth in Upheaval. Now, Earth in Upheaval was basically his gathering of evidence from geology, paleontology, mythology, that there had been catastrophes in Earth history. So he was completely outside the mainstream at that time. So I think I read his book, 75, 76, something like that. And then, then I discovered Hapgood's work. So I had gotten so fascinated by the whole phenomenon at that point that I set out as a goal to try to track down all of Hapgood's copious references. And there was like over 300 of them. So around 79 or 80, there's a science library here, not too far from where I live. And it's open to the public, but it's very underused. So I went in there and with my list of references and started looking stuff up.
Old school.
Yeah. No internet then. So
yeah, no. Like today, people can find out anything on the internet. You had to
I mean, I haven't even been to a library now in a couple of years because I can pretty much get almost everything. But so the librarian there got really interested in my research that I was doing. And then one of the astronomers there also got interested because he was doing work on, now this is, you got about 1980, see, was like a hinge point. 1980 is where you can really see things started shifting, because 1980 was the year that 3 separate teams came up with papers proposing that the extinction of the dinosaurs was catastrophic and not gradual, and that it was triggered by some kind of an extraterrestrial impact, right? The most famous was the Walter C. Alvarez and his team paper that came out in 1980, where they had discovered the magic layer in Italy, the iridium layer. Now, iridium is a platinum group metal that's very rare on the surface of the Earth because it's a siderophile, meaning it likes to bond with iron. So in the early days of Earth formation, when all of the iron, sank to the core, it dragged the iridium with it. So iridium is very rare on the surface of the Earth, but it's very plentiful in meteorites and asteroids. So the Alvarez team was looking at this Cretaceous-Tertiary Boundary, as it was then called, where below were dinosaurs and above there were no dinosaurs, right? So they were trying to figure out how much time had elapsed between, and so they were analyzing this little layer that's only 1 inch or 2 inches thick. And that's when they discovered that it was like 100 times more iridium in that layer than in the rocks above and below. And they said, well, wait a second, what is this? So they contacted colleagues, I think it was in Denmark, New Zealand, and a couple of other places, said, go back and take a look at the Cretaceous-Tertiary Boundary and see if you see iridium. And every place around the world where they looked at that boundary, there was this iridium spike. So apparently they realized, the whole planet got dusted in iridium. So what could that possibly mean? Well, there must have been an impact of a very iridium-enriched asteroid.
So before you said in the 80s, people thought the dinosaurs gradually, because I went to school post-80s, so I was always told it was a meteorite. I never knew that there was ever another, okay.
Oh, yeah. Yeah, well, this was, like I said, this was a major turning point in accepting that here you had a well-researched and well-documented potential of a globally catastrophic event. And so now when the paleontologists begin to look in greater detail, the span of time over which the dinosaurs were assumed to have disappeared shrank dramatically. And the more they looked, the narrower that window got. Of course, the smoking gun was always considered to be a crater. And the critics would come out and say, well, if you don't show us a crater, we're not going to believe this scenario because it's too far off of the accepted models of how this stuff happens. Well, eventually, 10 years later, they did discover the crater. In fact, it had actually been discovered in the early 80s by Petroleum Mexico, Pemex, who had drilled down into the northern Yucatan looking for oil. And about a half a mile under limestone, they hit this vitreous layer of this green glass-like material, brought it up, thought that it was volcanic. But somewhere along the line, some American geologists wanted to go take a second look at that. So they started bringing up more samples, and then they realized that was part of the melt rock. That, in other words, from the tremendous heat of this impact, it had melted the rock, and this was this glassy layer. So they then began to do subsurface geophysical surveys of the feature and discovered it's this vast 120 to 150 mile circular astrobleem is the word, astrobleem. There's a cool word you can use in your podcast now. Astrobleem, which literally means
cool name.
Star wound. Yeah. So you got this astrobleem, and it's been studied over and over, since the early 90s, and it's pretty much accepted now that, it's a gigantic impact scar buried under the limestone rock. And so, but at the same time, on the other side of the planet, there was this extraordinary period of volcanism that created the part of the continent of India, which was produced by these huge basaltic lava flows out onto the surface of the earth. And so there was the conflict then became, was it something from above, outside the earth, an asteroid that did the job, meaning, and the term for that would be exogenic, exo meaning outside, or endogenic, from inside. I think it's both. I think it's clearly both. And I think that the volcanism may have actually been a response to an asteroid the size of Mount Everest slamming into the Earth, at basically 10 to 20 times the speed of a high-powered rifle bullet. So coming back, this is like 1980. So this is kind of like this pivotal point where it suddenly became more respectable to talk about catastrophes in Earth history. So basically what we see for the next decade and a half is that it's becoming more and more acceptable to think about catastrophes and their role in Earth history, in evolution, in mass extinctions, and so on. Where we're at now, though, and for roughly the last decade, or at least since I think 2007, which was another pivotal year, is the question of what role has catastrophes played in human history. See, and I think that's where it's going now. And the more we look at that, the more it seems like this is a very relevant question to ask. And the realization, 100%. Yeah, totally. And so this is kind of like what brings us back to these ideas of lost civilizations. And you can imagine that if everything that is changing on the planet is so gradual that you barely notice it, one grain of sand, one drop of water at a time, well, whatever it is that causes civilizations to disappear, to collapse, it's not going to be some catastrophic thing from outside. It's going to be factors that are internal to the culture and the civilization itself, right? Or just some kind of vague but built-in senescence that causes the eventual demise of civilizations. However, we now know is that the Holocene, the last 11,600 years, the geological epoch called the Holocene, has actually had numerous catastrophes. Not on the scale of the catastrophe that wiped out the dinosaurs, of course, but certainly of strength and power capable of wiping out civilizations.
And the ancient Egyptians, like they knew this from like the get-go, and they were telling Solon and everybody, like we've got recorded history.
There have been.
They were more clued up to it than we are now in the 80s. Yes.
As they told Solon, there have been many destructions of mankind from many causes, but the two primary causes, fire and water.
Okay.
And now in like the thing we've been doing with the tours we're doing out in the Western United States is because some of the imprints of these gigantic floods are just so spectacularly displayed. And it's only within the last few decades that, there's been this acknowledgement that some of these landscapes were in fact carved by floods that are almost on a scale that are almost impossible to visualize because they're so massive.
I'm so impressed that you, as a young boy, could see that, because you didn't have Google Maps. Like now you can see everything from a satellite and you can see everything that you're explaining. I really thought, Randall, you were going to say that you went up a hill and fell down a pothole and had like an epiphany, but you didn't go that way. So I thought you were going for with the pothole thing.
Well, hey, maybe I should change my story then.
Yeah, I fell down a pothole.
I fell in a pothole, yeah.
I fell in a pothole. On Grateful Dead jam that story that way though.
Yeah,
but that's a pretty good story.
I like my light bulb moment was I found Jimmy from Bright Insight, and he did a video on Atlantis with the Ricat structure. And that kind of blew my mind. I was like, oh, wait, what? Hold on. And then when I sort of started to Google and look into Atlantis, and obviously I saw you and Graham on Joe Rogan, and sort of that video versus that video and a bit of research. And when I found out that the date of the Younger Dryas comet impact was identical to the one that Plato wrote, that was what convinced me, and I kind of haven't looked back. And that was my literal jump into the rabbit hole. And then I spent the entire lockdown just doing that. Like there was like 6 months of hardcore YouTubing before I decided to actually go out and see these sites. And I encourage anyone who is like thinking about it, like I know it's a lot of money to go and see these sites and go on the tours. I appreciate that they're expensive, but go and do it. I'm gonna plug your tours, Randall, because they just, it's like a once in a lifetime opportunity to see this stuff.
Yeah. One bit of clarification. Plato's date, 9,000 years prior to Solon, puts us at 11,600, which was the end of the Younger Dryas.
Okay.
not the beginning, the end of. So the Younger Dryas dates from right around 12,900 to 11,600. Now at 11,600, there was a massive meltwater pulse into the global oceans. It's called meltwater pulse 1b. So in a way, like you, that was for me, that was actually kind of an epiphany for me when I realized that Plato's date and the date of meltwater pulse 1b coincided precisely. And I go, wait a second. So there was a rapid, what geologist John Shaw referred to as a CRE, a catastrophic rise event. Then that was for me, that was kind of, I think my turning point, I was just kind of a skeptical. My thought was that Atlantis was just a story. I didn't necessarily think there was any literal meaning to it. But then I read a couple of books, late 70s. One was by German physicist Otto Mook, The Secret of Atlantis. And the other one was by R. Cedric Leonard called The Quest for Atlantis. And they were both coming at it from a relatively Otto Mook was a physicist. So he came, and his theory was, and this came out, was it 78 or 79, right in there. His theory was that there was an asteroid impact that caused massive seismic activity that ultimately sunk Atlantis. So he was proposing that idea pretty much right around the same time as you had these other scientific teams like the Alvarez group and others proposing that the Cretaceous-Tertiary 66 million years ago was terminated by an asteroid impact or a comet. They were, at that point, they were not sure which it was, just that there was something from space that took down the Mesozoic, the era of great middle life, right? So he was coming out with that idea. And I read that book right around the same time that I was seeing this information about the KT boundary impact. I thought, well, interestingly, and then it was in that book that I had actually first heard about the Carolina Bays. And I don't know if you are familiar with the Carolina Bays.
I am, from your work, yes.
Oh, and to this day, yeah, I'm very impressed, Jahannah. I'm very impressed. If I was a professor in a university and you were in my classroom, you would have at least a couple of gold stars up on the.
Right. Oh, I got a gold star from Randall Carlson. Yeah. Yes. Winning. Okay. Yes. But Carolina Bays, I'm with you. I can picture, I know what they look like. Yes.
Okay, good. Well, see, to this day, I haven't made up my mind about the Carolina Bays. They're mysterious. Okay. But at that time, Otto Mook proposed that the Carolina Bays were created because an asteroid coming into the atmosphere began to spall, which is the outer layers of it fragmenting off. And it created this swarm of impacts over the southeastern coastal plain of the United States. And that's what created the Carolina Bays. That was his idea back then. So that was the first place I ever heard about the Carolina Bays. So when I was going to this local science library that I mentioned earlier, that was one of the things I was also looking up. I got a hold of a book called The Mysterious Carolina Bays by Henry Savage. And he said in the book, he says, in my list, my bibliography, I'm trying to put every single paper that's ever been written on the Carolina Bays. So just like with Hapgoods, I said, okay, I'm going to have a goal. I'm going to try to get a hold of every single reference he's got and read every single paper on the Carolina Bays. And I pretty much did that. And then I mentioned, I also had this friend of mine that was an astronomer that I had gotten to know by researching there, called the Fernbank Science Center, putting in a plug for the Fernbank Science Center. And he was researching the Eocene-Oligocene boundary, which was an event that occurred. It was a geological boundary that occurred around 35 million years ago. And there was a mass extinction event. Around that time, a geologist by the name of Wiley C. Pogue discovered that Chesapeake Bay, which is right next to Washington, D.C., at the bottom of it is a 50-mile wide astrobleed. And he dated that, and it came up to be about 35 million years old. So it coincided with this extinction episode, right? Well, in Georgia, there are these tektites. Now, do you know what a tektite is?
Not a clue. Okay,
a tektite, if you have an impact, a hypervelocity impact, it completely melts the rock, right? And just as an impact into any liquid would cause a splash effect, and then that splash would fall back, Tektites is the splash that goes up and it falls back. It comes back as liquid. And as it's falling through the atmosphere, it takes on a variety of aerodynamic shapes. So there are, just south of Macon, Georgia, there's an outcrop, 35 million year old outcrop, and it's on a hill. There's a place called the fall line. And in Georgia, the fall line marks where the transition from the Piedmont, which is the foot slopes of the Appalachian Mountains, there's that 35 million year old outcrop. So what happens is when you have a heavy rain, it'll erode that bank, and right at that 35 million year outcrop, tektites will get exposed and lay on the surface. Billions or trillions, you have to picture over the whole southeastern United States, this stuff is raining down and laying on the land 35 million years ago. Well, now over 35 million years, that's become buried. So there's this one little slice, one little strata that's exposed at this fall line. So I went down there on several tektite hunting trips with the astronomer, who's also a PhD astronomer and PhD geochemist. So I went down there with him on these tektite hunts. Turned out he was interested in Carolina Bays. So we would then go and we would visit Carolina Bays. Eventually I hired a pilot. We flew over, and this was even before I met Brad. And I took photographs of the Georgia Carolina Bays from the air. Did a lot of study in that. Thought I had it figured out, but I'm not convinced anymore because there's a lot of different evidence that's coming together, but there's still a mysterious phenomena. So a lot of this stuff was coming together in the early 80s and in the 80s. And so that's kind of where I kind of walked into the whole thing. I think Brad and I did our first serious field trip in 1998. Because the other book that I read on Atlantis around the late 70s, besides the one from Otto Mook, was this one by R. Cedric Leonard. And in that book, he had a chapter called The Cataclysm of 10,000 BC. And in that chapter, he talked about the scab lands of Eastern Washington. And when I read that, I go, okay, I sort of remember that, because coming back late summer, early fall of 1970, me and my buddy are coming across the Cascades, and we drove across Eastern Washington, and we drove through the scab lands. I wasn't nearly as impressed by what I saw then, of course, because I wasn't seeing the really magnificent stuff. But I did remember the scab land. Yeah, I've been to the scab lands, drove across the scab lands. So he's talking about J. Harlan Brett's and these tremendous, gigantic floods. So I think that was the point. And this is, again, maybe 90, 91, right in there somewhere. Well, so then I got really interested in the scab lands, and this is how I do things. You know, I set out, okay, I began to look into bibliographies, and there was, dozens and dozens of papers written since the early 1920s. So I set about collecting all of those together, reading everything I could find on the scab lands. And then when I met Brad, which was about 96, I believe.
Yep.
I think I was doing a presentation. Was that the one where John Anthony West was at? I think it was, wasn't it?
I think it was.
I think that's where I met John. Yeah.
Late 96.
Yeah, about late 96. So instantly, Brad and I hit it off because Brad was very interested in the same kind of stuff. By 2 years later, we'd become good friends, and we decided we were going to do this first expedition together, Eastern Washington. So me and Brad and a couple of friends, we went out there and spent a couple of weeks. The next summer, we went to British Columbia because I had concluded that the explanation for these giant floods was not correct. And I wanted to find evidence that would support or bolster this idea that the conventional explanations that were now being accepted by the geological community were not correct.
And are they accepted now, like properly? Like, is the theories, like, how close are we to it being?
Well, the existence of the floods is accepted. And because once you spend a week or two in those landscapes with even just a smattering of hydrological knowledge and stratigraphy and that kind of thing, it's just obvious. There's just no way around it. You're seeing, and what it is, it's you have this suite of features that each time you add one more element, whether it was a pothole or whether it was a slot canyon or whether it was a recessional cataract or whether it was a giant boulder bar or any, the list goes on of the features that are produced by giant floods, right? Well, you could take one of them and say, okay, you could come up with maybe a sort of a quasi accurate explanation of what might cause it. But it's when you put the suite of these features together, every time you add a new type of feature to the mix, it becomes more and more impossible to explain it by some kind of a gradualistic process. The geological community accepts that there were these giant floods, but their theory is that there was a giant lake held in by an ice dam in western Montana. The ice dam was a half a mile thick. The lake was 2,100 feet deep at the ice dam. The ice dam gave way. The lake drained out. Then the ice dam grew back and the lake formed again, burst through the ice dam, and it did this repeatedly. Now, this model is based upon the observation of modern glacial outburst floods that are seen Iceland, British Columbia, the Himalayas, anywhere where there's mountain glaciers. And particularly within the last century or two, there have been a lot of those because the planet has been coming out of this 500-year-long period of cold called the Little Ice Age. You ever heard the term the Little Ice Age?
Yes.
Okay, good. The Little Ice Age was a period of time where the glaciers worldwide grew to probably the largest extent they had been in 10,000 years since the end of the Great Ice Age. When those glaciers began to shrink back, you had a lot of lakes that formed in the valleys. They're called proglacial lakes if they're in front of the lake, in front of the glacier. And you had a lot of these lakes that formed, and then they would eventually fill up to the point where the pressure got great enough that it was able to burst through the containing glacier and drain out. There are a lot of these. The term that's often used now is from Iceland called jökulhlaups. A jökulhlaups is this outburst flood. The problem, though, is, and so what the geological community does, that within the framework of uniformitarian thinking, the basic working premise is that we look for things that are happening today that we can witness firsthand and extrapolate backwards to, thousands or hundreds of thousands or even millions of years ago. And the idea is to explain things that we see that were formed in the past by analogs with the present. And so one of the things that helped the geological community, who was very resistant to this idea of mega floods, because, oh God, we're getting back to biblical literalism. And the next thing you know, somebody will be talking about Noah's flood, right? They were very resistant, right? But then when they saw the possibility of this uniformitarian principle, which, oh, hey, we've got modern outburst floods. It's just one of those, only bigger, right? That's kind of pretty much how it has progressed. Now, since 98, God, how many trips have we done now, including all of them? Up to 40 or 50 or something?
Yeah, we're 40 plus at this point.
Yeah,
happy to say, like she said, grateful. Yeah, these things cost money, but things have fallen into place to allow us to do these things and
that's amazing.
Get that research done.